All right, so today we are looking at active recon and then a little bit of enumeration. So do want to go through that as well. So back to our slide for the day, I think. Yep. So we're going to share the screen. Wait, I think I need to show something from last week. So last week there was this video I was supposed to show that I forgot to show. So present a view. I got this from Kate, one of our professional instructors. Let me reshare this and optimize it for video viewing. Optimize for video clip. All right. Let's go. So we're going to have like a little movie session. All right. So you can dim the lights in your room and enjoy the movie. All right.
So I invited a few of the world's best hackers to try to hack.
Can you hear?
Yes.
Okay, good.
Yeah, we hear you.
Hack me and show me where my vulnerabilities are. And now I'm going to meet them in Las Vegas for DEF CON, the biggest hacker convention of the year. They're going to hack me using social engineering, which is essentially hacking without any code. They just use a phone and an internet connection.
Do you want to do a sample phishing call?
What's phishing?
Phishing is voice solicitation, and basically what you do is you use the phone to extract information or data points that can be used in a later attack.
Let's do it.
Okay.
Who are you going to call?
Maybe I'll call your cell phone provider and
Okay.
see if I can get them to give me your email address.
I bet they're good. I bet they have my back. But yeah, go for it.
I'm going to spoof from your number, so it's going to look like it's calling from you.
Okay.
Hi, I'm so sorry. Can you hear me okay? My baby, I'm sorry. my husband's like, we're about to apply for a loan and we just had a baby and he's like, get this done by today. So I'm so sorry. I can't call you back. I'm trying to log into our account for uses information and I can't remember what email address we used to log the account. The baby's crying and can you help me? Awesome.
In just 30 seconds,
At gmail.com?
Jessica gets access to my personal email address.
Now, if I needed to add our older daughter on our account so she could call in and make changes, how would I need to go about doing that? You would have to send me a secure PIN through a text message? Yeah, well, the thing is, I don't think I'll be able to receive a text message if I'm on the phone. Shh. Oh, I'm not on there either? So I thought when we got married, he added me to the account.
Jess uses my girlfriend's name and a fake social security number
5127.
to set up her own personal access to my account.
Wait, I'm sorry, so there's no password on my account right now? Can I set that up?
She even gets the support person to change my password.
Thank you so much for your help today.
So she just basically blocked me out of my own account.
I'll get her fed after this. All right, thank you.
Holy shit. So they just gave you access to my entire cell phone account.
You're gonna have to go on and change your password now because it's Jess, my name.
And all it took was a crying baby and a phone call.
Yeah.
Okay, movie time over. But then I think you all get the idea, right? How easy it is for this to work. And I mean, she's good. She's good at it. I'm very impressed. I wish I had this risk, but it is good and very scary as well. Because the thing is, people trust easily. And once a lot of things are happening at the same time, people tend to not focus on the important things. So like, they are hearing the baby cry, hearing you in distress. They feel like they have to help, human nature. So that moment, it's like their guard is down and then they keep, they tend to be too vulnerable at that point, and then you get the information you want. Which here is, all right. So that was from last week's class. All right, so moving to today's class, right? So that was a little demonstration from the social engineering bits. My bigger concern though is the fact that people would watch baby crying videos on YouTube. Oh man. All right. So today we are going to take a look at wait, let me switch this up real quick. All right. So today we are going to look at how the web works, HTML, CSS, HTML forms. Some of you would already have an idea of this, but then we are going to take a look at it because we are now going to look at some web scanners available and how they operate. And in order to understand that, we need to know what goes into all of this, right? HTML, CSS. For you to see a website, right? For you to see any website, there is some background information that you need to take a look at. So it's going to be some interesting content today. So we are also going to look at DOM manipulation, manipulating the objects on a web page, percent coding, HTTP response codes, session and cookies, scanners, enumeration, and then we'll do some scanning and enumeration demo based on what we've talked about here. And then MSF Venom, our first group project. And then next week, we'll have like a major group project with MSF Venom. So today we are going to do our 10-minute tactical as well using MSF Venom. All right. Now, let's go back to last week. I mentioned that when you visit a website, your details are literally on, they have your details, right? So for example, I think this should be a firewall of one website that I used to manage, right? So for example, this guy just visited the website, so the thing is that every second, okay, let me zoom into this. Every second, websites are being attacked every now and then. So most of these attacks are automated. They are automated tools that are getting this done. You won't have a human being doing this. No, it's an automated, it's a bot, right? So you will notice that, I wish I could get like current ones, but you will notice that some of the time difference is very similar. So this guy tried to access this website, but then he was locked out because I have a web application firewall on the website, right? And the IP address, this is certainly a bot, it looks like a bot. The IP address is here. And then the browser they are using, right? Windows NT 6.3 on and on, Apple WebKit, Gecko, Chrome, Safari. If I go to see recent traffic, if they visited the site before, that information would also be stated here. And specifically where they are is also listed, right? So here I have the IP address because it's a firewall, and this is a WordPress website. This is the administrative panel of a WordPress website. So all of this information is available when you visit a website. And then this is actually a chat bot that is used on another website. And I'm going to show you something, right? Once someone visits the site has lots of tracking. So this is good. So the person is communicating with a bot, right? But then the location of the person is stated here. The device they are using is stated here with the version they are using, right? The iOS version 15.6. And then also the web browser version they are using. So once you're on the internet, every information is available. I used to have a chat bot that it locks your IP address, where you are, your specific location. I think the location is based on your ISP. So it picks all of that, and all of this is available through the internet. So that is why it's always important to protect yourself whilst you are on the internet. So firewall giving all this information, plus a chatbot giving all this information. It could go as deep as you want. Some of them can go as, if you use Google Analytics, Analytics, it goes as far as giving information on if you are male or female, right? It gives information that on your website, 50 of them that visited were male, 60% were female, on and on and on. All right, so let's carry on with today's class. And I was supposed to show this chart last week when we were doing the footprinting. And we have three main phases. The first phase consists of footprinting, scanning and enumeration. The second phase of attack, I mean, you know, we have several attack models, right? But then we are just separating our phases into three, where the second phase is exploit and attack. We do the exploit, and then whatever we need to do after that, we do it. And then step 3 or phase 3 is where we decide to maintain assets. So today, last week, we looked at footprinting, and today we are looking at scanning as well as enumeration. Okay, so all right. So how the web works. Now, this is an interesting concept. It could go as deep as we want, or it could go as quick as we want, but I'll try as much as possible to explain the logic behind all of this so that we could all understand it as easy as possible, right? So HTTP Hypertext Transfer Protocol HTTPS was created around 1990. I may be due on the year, but then the whole idea is whenever you request for a website, as you're seeing here, your information, every website is being held on a server, right? Whether it's a local server like my laptop or it is a remote server, it is still a server. But then the idea is that servers could be a rack, where I think that's the idea people have about servers, where we have this thing going on where you have something like this. And then we call it, oh, there's a server or there's a workstation, right? But then I could install a software server on my laptop, and then my laptop becomes a server as well. So most of the time, the ones that you see, maybe you see a Google data center with so many servers. Yes, those ones are different, but then you could also install a server on your laptop and then set up a website and everything works. So in this case, when you are home and you want to maybe visit google.com, I think I've done this diagram before. When you put in google.com, right, it goes to it finds Google's IP address, goes to that location, and then once it gets there, Google would give a response. So Google gives a response, and then it comes back to you, and then you see it on your web browser, right? Now that process where information is going and you are receiving a different set of information back is the request response process, right? The request response cycle. So whatever you sent went onto Google's location, wherever their server is, it was processed. If you asked for specific information, it was processed, and then you received a response, right? Now, in terms of requests literally come in, like there are several sections to a request, and we are going to see that in our terminal shortly. So with the request, most of the time, request could be in two forms, right? And it could be a GET request or a POST request. Now, when we say a GET request, let me show this on the browser, right? I think Matthew had a nice explanation for this, and I would mimic that shortly. All right, so if I go to right, that process of me doing this, putting in google.com, and once I receive this response, it means that the request response cycle is done, is complete. All right. Now, if I decide to search for something in Google, right? And these are my searches. Interesting. Anyway, so if I decide to search for something like hello, right? If I do this, you will notice that I've sent another request to Google and I've received a response. You are going to see a different explanation of this later. But then when we look into the URL, I hope you can see the URL sections. So let me zoom this in a bit, right? Oh, the URL does not zoom in still. But if you look here, you're going to see search with a question mark. I'm going to try and put that here as well. You're going to see search with a question mark, kill is equal to hello. And then the source is equal to whatever it says. It goes on and on and on. Google knows what it's doing, right? But then the most important part we need is this guy here, right? So google.com google.com/search, right? We don't need this guy, so we are going to take him out. And whatever I did is what I get. So once I put in hello, Google now requests for that resource. So Google will make a request again, and then the response will come back to me. So as you check, This queue here, sometimes it could be query. It depends on who is coding it. It could be query, it could be question, it could be anything. Whoever developed the site decided to use queue, and whatever I put in there in the search bar was actually put in here. If I do hello by Adele, it is also going to change. You are going to see hello plus by plus Adele. We are going to also look at that shortly, why the plus is there, right? So in a way, this type of request where whatever you are asking from the server is being showed in the URL section, we call this request a GET request. So that is a GET request. When you see whatever you put in there, whatever you are asking for in the URL, some sites are so weak. I think I used to, those times when I started developing, right? You could have a site and then maybe it could be like this. Let's say the site is for login, right? So you have a site like login.com, and then you have something like maybe username is equal to, this is just an example, right? Username is equal to Derek, right? And then maybe end password is also equal to Derek, right? Or let's say revenge, based on what Zori asked me earlier. So my password is revenge. So in this case, right, when you see these things, you are logging into a site and you see that your username and your password is actually in the URL section of the browser, it means that that site is using a GET request, which is very unsafe because it can be hijacked. If someone checks your internet history or your browser history, they could see the credentials you used and they could just pick it up and then use it for any other attack. So most of the time, we advise that if developers should use post requests whenever they are dealing with logins or credentials or stuff that are important as that, right? So requests mostly targets a URI or a URL, right? Uniform resource locator, which is a web address, okay? And these requests, let's get back to our slide. These requests, as you're seeing, these requests are mostly characterized by methods. And these methods include, these methods could also be termed as verbs or actions. So with every request, most of the time, a request is just to target a URL, which could be google.com, codingdojo.com, derek.com, any other website you want to visit, right? And then, as I said, requests have verbs or actions or methods that they have to use. And these methods include, so the first one, I need text, right? So one of the first ones is we have gets, just like you saw, right? And that is, in simple terms, to go to a website or retrieve a website. I'm going to make this as simplified as possible. We have post, which is mostly used to send data to the server, right? Data to the server. So data such as maybe blogging, maybe commenting on a blog, right? Because you don't want to put that in the URL section of the browser. And then we have puts or patch, which is mostly for updating stuff on the server, but it's not relevant, so we are going to take that out. It's just for updating stuff on the server. We have deletes. And then for deletes, it's just to remove a resource on a server. Let's make it data server. And then we have head or options. Now, these mostly gives you information about the server's capabilities or functionalities. So retrieve server capabilities, right? If you get to the head, we are going to make a request shortly, and then you're going to see what I mean by all of these things. And in order to understand these better, I need to pull up my terminal. I need to reshare to my terminal. Where are you? let me know if you can see my terminal. All right, head requests are going to be very useful for CTFs. Exactly, David. So, okay, you can see my terminal. So head requests, as I said, the capabilities of the server. We are going to see that shortly. All right. So in this case, we want to see how these things work, right? And I think this is too small. So Control plus. Yeah, that moment when the Control plus doesn't work on Mac. Oh my God. Oh wow. Okay. Very disappointing.
Derek, I think Zori has a question.
Sure.
Sorry, I was typing it. I know you said earlier that they're trying to teach software developers to not use get as much because it's not really a best practice to building a site. So if get is what loads up the website, how can developers maneuver around that? I don't know. I guess I'm a little confused with the whole get and post thing.
Okay.
It's like, yeah.
Are you done?
Yeah, I was just trying to figure out, like, is there another way to load up a site without it being a get type of request, or?
Okay, so that's a good question. So I think what I meant to say was that it is not advisable to use get request when you are dealing with credentials, right? Or let's say secret information like when someone is trying to log in, we tell developers do not use get requests and responses when you are dealing with logins. So if you are retrieving a website, it's fine. If you are just visiting a website, it's fine. But then when it comes to dealing with logins and information that is a bit secretive, you don't have to use get requests. It is advisable to use post because post will not show it in the browser. It would transport it differently. Is that clear?
Yeah, thank you.
You're welcome. All right, so I'm still here trying to improve trying to get this thing to look bigger, and it's just not responding. So let's carry on. I hope it's clear, right? So is the screen clear, right? All right, +1.
Yeah, that's good.
All right, so we are going to use the tool curl, right? I think you met curl during your setting up Metasploit with 3, where you had to put in a curl request, and the curl is actually used to sort of retrieve resources from web servers, right? So we are going to use those curl requests. We are going to make a curl request to specific websites and see the response that we get back, all right? So I'm going to do something like curl, and then if I put in google.com, it's going to, when you put in google.com in your browser, what you get is the browser processes that response and then gives you a visual representation of that response. Now I'm going to show you what happens in the background without you seeing what is in the browser. So if I do curl google.com, all I get is, this is supposed to be HTML code, which we'll look at shortly, so we can ignore that. So in order to get more information, we add verbose, right? And if I do verbose, the information is a bit much. Let me clear that. Do it again so that we have a clear screen of that. All right. So now what we have here is there are 3 sections, right, of information. There is the first section here. There is a second section here. And then there is a third section here, separated by, I think, new lines. We call these new lines. All right. So let's take a look from the beginning. And we first of all have, so as you can see, we have it started to connect. If it's using HTTPS, it's going to show the HTTPS, the TLS connection negotiation and everything, but it skipped all of that. And then first response, once it's connected to the victim, right, connected to the target, which is Google and the port, first thing we got was, as you can see, the method that was used to so this is the request. Sorry, let's get my annotation here, right? So all of this is the request. Now all of this, yeah, they all start with RE, right? Response, then REQ here. And then this would be the body of the response, right? So this is related to the response. Body related to RESP. All right. So with the requests, what happened was that we are requesting for a particular resource, right? And the method we use to request for it is the GET request. Then what you see here is the root resource. That is the root page on the server. So that is why you see this / here, right? And then the HTTP version that we are trying to retrieve. So HTTP/1.1.1, meaning that we are trying to get an HTTP page, a hypertext transfer protocol page, and we are requesting for the root resource, right? Or the home page, in other words, okay? Then the host or the target, as you can see, there's a colon. So the target or the host is google.com. Now the user agent we used, right? What we used to make that request is curl version 7.6.4. If you use a browser, when I showed you the firewall information, you could see Safari version 15.6 on and on and on. That would have been here if I was using my iPhone for that or my Safari for that, right? Then we have, these are the things that the server can accept, right? It can accept everything. When we get to SQL, we'll get to see these wildcards. We call them mostly everything. So then the response came from the server, which includes HTTP 1.1.1 response, and it's giving us this error code, which is 301, and we'll see that shortly. But 301 mostly means that it's been redirected, meaning whatever page you're looking for is no longer here. It has moved to this new location. So that's why we have 301 moved permanently. 302 will be moved temporarily or moved temporarily. Now the location or the page we were getting, as you can see, we just did google.com, but what we are receiving is http www.google.com. Then you see the / at the end, which is the same as this. And then the content type is text or HTML, the dates, the time this page or whether it's cached or something would expire, cache control. Cache means you are keeping a version of the page so that they don't load that page every single time for you. Okay, and then server, I think this would be Google Web Service, right? Yeah, the server is a Google Web Server. And then content length, XSS protection is 0, same origin. It's also there. And then now the HTML page is actually here. So this we are going to look at shortly, right? The HTML page. So that is how a curl request works. And you make the request to the server. So then on your website or in your browser, like Google Chrome, once you go onto this, once you type in google.com, what you get in return would be this part of it, the process response. So your Chrome would pick up this response, which is HTML code, and it would show it to you, like it would sort of show you the visual representation of what we are seeing here, and then connection is closed. Now, in this particular case, they have redirected us to a different page, but we did not follow the redirect. Let's do one more thing to see if we can follow the redirect. So we are going to use the same command, but then with curl, there is an extra switch we can add that can follow redirect, and that is the L switch, which means that if it gets to a page that has a 301 or redirected to a different location, we are asking curl, we know that this page has been moved, but then this L switch is telling you to follow to that new location, right? Just like an Amazon package. If you've changed locations, it gets there, they'll tell them, oh, no, is this other location? And I don't know if they do that, but they'll move to the correct location. So I'm going to do that again. And then this is a lot of gibberish because Google has a lot of secret code on their website. Let's see if I can get this to meet. Yep, perfect. So this is the request. Where is our good? This is the request. Google.com, the same thing, but now we want to follow that redirect. Okay. So as you can see, we get the same response again, same thing, moved permanently. And then there's another response. Instead of the HTML code, there's another one which is telling us that, yeah, we know that you are looking for this page, but then it has been moved. And then let's see. So it makes another request. And then we get that response here. I think this is the, let me clear this, all of this annotation. Clear my drawings. All right. So this part is the new response. This, so now we have two requests. First request, it was redirected. So it performed another request to the new location. And then we got this response. And in the end, the response we got is all of this HTML code with all of Google's secret codes in there trying to track a lot of information. So that is how HTML requests look like. The request, the response, and then the code, right? So back to our slide. So then if on a page, let's say this page, there's a way to view those same things. You could just do, wait, let's go to a page I know, right? So that we could see all these requests, right? Good. All right, so this is one old page I made in the past. Please do not attack. Can you see the things at the bottom? Let's. Ooh la la. All right. So what I did was I right-clicked on the page that I visited and I clicked on inspect because I want to show you the request. We've seen how a get request looks like. So we are going to see how a post request also looks like. So we go to ignore all the places I'm going to. I just want you to see something. So let's see anything else. This is not going to work. Oh my word. All right. So that excesses going on here. Let's log in the PHP. All right. So as you can see, can you see this? Oh, this is too small. Increase the brightness. Oh, it doesn't affect this side. Huh. Oh, this is too small. Just a second while I figure out how to make this so big. There should be zoom somewhere. Please don't do that. But anyway, I just wanted to show you that this is the request headers that were used to request for the page. See the method is posts. It's too small, but really apologize for that. All right, so the method is post. The page I was requesting for is here. And then my response is also being showed here. I just wanted you to see if it was get, it would have been different. And if it was post, it would have been different. I'm using post because it's a login page. And that is why I'm using post. So back to our slide. All right, now there is HTML CSS, right, which is basically the motherboard, like I want to say the backbone. All right, so yeah, Erica saw it. Good. I hope the rest of you saw it. The request would be different based on what you are asking for or what you are receiving, and all depends on the server. So you could make a request to the server, but then the server decides whether this information I'm giving back to you, do I have to give it back to you in GET or do I have to give it back to you in POST? If you make a request that a server does not want, the server can give you a response. For example, if you make, let's do one more thing. this is unrelated, but let's just do one more thing in the terminal. All right, let's do one more thing in the terminal. We are going to make a request. This is too much. Wow, now Claire is not being found. Oh, wow. Just a sec. Terminal. Okay, we sharing the screen. All right, so same request we did. Come on. All right, so we are going to do curl, right, with the big X. So when you do X in curl, you are trying to specify the request method, which would be get or post or put delete. So v and then google.com, right? So you see, the only thing that has changed here is that at this point, I'm specifying the request I want. And once I do this, I would get something along the lines of good. Referrer, assume close after body. So post for google.com. Post request post requires a code. Header, blah, blah, blah. This is quite messy today. Let's see. All right, so HTTP 411 length required. So as you can see before, I was getting a different request, but now I'm getting a 411, which we would see that in the other slide, which explains the response code. So every response has a code, and we'll get to see that as well when we move to the other sections, all right? All right, so now that we've understood what requests and responses are and how they operate, now we have HTML and CSS, and HTML is, with HTML, it is like, these are all web languages, and HTML defines, when you visit any page, whatever you are seeing, the structure is being defined in HTML, hypertext markup language. And then we use CSS to sort of style it up. And then there's another guy on the side named JavaScript, who is just for functionality, behavior, sort of programmatically change or modify or adds more functionality to these two guys, all right? So there are so many differences between them. With HTML, you can insert videos, images, and all of that. But then with CSS will place those images in the proper location. So let me open up, let me use Microsoft Word to sort of show what HTML, CSS, all of that can give you. Search Word, reshare. I'm looking for Microsoft Word in my sharing panel, but it's not showing up. Oh, but it's there. Come on, brother. All right, let's just share a portion of my screen. All right, can you see my office?
Yes.
All right, so where did this guy come to? Good. So I think you've all used Microsoft Word before. You use it for your assignments every single day. So in this way, right, I hope it's big enough. Let's say you want to say this is our heading, right? And then we say this is our body, all right? Now the heading, most of the time we need to provide we need to make it so big and all of that. But then we have these shorthanded stuff, which makes it easy for us. So I'm going to pick just heading 1, right? It's already styled. We don't need that styling. So I'm going to make that black. And then the body, right, it's here, okay? So I'm trying to get you guys into HTML, CSS. For those of you that know it, fine. But then this is every web page you see, no matter the language they're coding, at the end of the day, for the browser to sort of show us that representation, it will be converted to HTML document object model for us to see. So same as what Microsoft Word does, right? You are able to, so this thing you are seeing here is our HTML, all right? This is, I'm defining the text, the structure, everything. This is our heading. This is our body. This will be maybe an image. Let's ignore images for now. Let's just say I want to put something like, this is our conclusion, right? So we are writing an amazing article for New York Times. Conclusion. All right. So I want to make this header big, right, by increasing the font size. And we are going to do all of this when it comes encoding. So I'm going to increase this font size to, let's say, 22. I'm going to make it bold to sort of show that, yeah, this is my header. And maybe if I want, I'll just align it to the center. Right, so that's our center. And then for the body and the conclusion, I will just change maybe I'll change the color to, let's say, blue, right? And then maybe I'll just center them as well for extra effects, all right? So all these things we've done, right? The point where I was defining this is the header, this is the text, this is the body, this is the conclusion, all of that is HTML, right? Now, at the point where I'm trying to style or sort of provide extra, like I'm trying to beautify the content or provide extra beautification, that is the CSS part of things. So the point where I went in here to change the color, change the alignment. So anything that doesn't have to do with the text or the content, that is your CSS. Anything that has to do with the presentation of the text, all right, or presentation of the document. So color is that. If I change the alignment to left align, you can use CSS for that. That is the job of CSS. Where things are positioned on the screen is the job of CSS. Now, JavaScript will come in later for extra function, but then this is the two main things we need to know about. Your document or the content of the document, and then the styling of the document is solely dependent on these two guys we have here. And there are tags, and we are going to look at all of them shortly. All right, so this is an example of an HTML form, right? So HTML form is an element used to collect input. I think we've all seen this on so many sites. This looks very standard because it has not been styled yet. So if we provide styling to this, it would look amazing. We can make this longer. We can change, maybe we can make sure they all align on the same line, right? We can sort of beautify this a bit, and we need CSS for that. So then with HTML, right, when it comes to forms, we have checkboxes, which we all know what checkboxes are. And then we have text. Text is what we see here. Radio buttons are these guys here. We call them radio buttons. Now, a date input method for a form looks like this. Once you specify that this is a date, it would do all the formatting for you. A text area is, so for this, you are able to put in text, but then on one line. So this is what we call a text element, right? But then this is a text area element where you are able to have a multi-line section to put in your text. And then we have a drop-down list. This qualifies as a drop-down list because once you click on this, you would see a lot of things in there. Now, the HTML parameter it's a tag used to define parameters for an object element. You would see that shortly. And in view of that, we are going to move on to a little bit of coding to show how this works. And then we'll jump into the other sections for the slide today. So I'm going to pull up my Visual Code Studio. Visual Studio Code. All right, pulling it up just a second. In the meantime, if you have any questions, you can ask. If there's anything you feel like I went too fast on it and you want clarification, you can ask for that as well. All right. Okay. I'm still booting up my Visual Studio Code, so just give me a second. New share Visual Studio Code. Let me know if it's big enough. So today we are actually going, we are getting our hands dirty. You are not supposed to do any of this. I'm using this to demonstrate what HTML code is, CSS is, and then we get to understand what we were seeing after we did the request response. The body side, what was there, that was HTML. So that is going to help us understand that as well. So HTML pages, as usual, they have the .html extension. So I could just create a new page and then name it anything I want. We could name it professional.html. So once you put in the extension helps the browser know that, okay, this page I'm about to process is an HTML page. So let me use these parameters to process them. So we have a professional.html page, and this is how HTML pages look like, right? So first of all, certain things are defined, which is the document type, blah, blah, blah. We don't want to focus on all of that. But these, this is a code editor. And wait, is the text, if I do this, is the text big enough? Let me see if I could make it bigger. Just a sec. Appearance. What is the shortcut?
That's good. That's good.
Control equals sign. Okay. Beautiful. All right. So now this is basically just saying that the document you're about to process, we are telling the browser the document you're about to process is HTML document. And we also want to say the HTML document you're about to process, the language is English. All right. Ignore all of this. Sometimes you could just go straight and then just start coding your stuff and it's going to work. I think I used to do that in the past when I don't have time for all of this stuff. All right. Now, as you can see, this guy here is just defining the document you're about to work on, right? But then this HTML language, English, supposed to be English, EN, right? As you can see, this is supposed to be like a tree, right? And we are going to see the DOM shortly. But then we have, once we open this tag, you will notice that tags, these are called HTML tags. And for HTML tags, they define the structure of the page. We call them tags, right? They define the structure of the page. And now we're about to define, it's just like you are building a house, right? You need to specify this house I'm about to build. I will need a roof at the top. Besides the roof, okay, no, don't do that. Besides the roof, I will need something like, let's say I have no idea how to build a house, but let's say we have some wood right below the wood, below the roof. So maybe some wood, right? Then the next thing we'll need is maybe more wood for the structure, right? Then we'll come down with, let's say the floor, right? So in a way, what I'm doing is that, let's say we'll need bricks at this point. So let's use bricks. All right. So we are trying to build a house, but then the structure of the house needs to be defined. We will need the roof at the top, the wood at the right below the roof, the bricks, the floor, and then anything else we need. So this, at this point, we've defined the structure. So same with HTML, right? We are trying to define the structure and we need things called the tags. So every tag opens like this, right? And then it closes like this. There's a / and then it closes it. So let's say if I have a tag named Derek, once I open it, if I do this, the one at the top, it means I've opened it. In order to close that tag, where I'm telling the page that I'm done describing Derek, I need to do the / and then put in Derek here. I don't know why this guy is reflecting our changes. It's weird, but let's take this off. All right, so if I need to close this, as you can see, right? So if in case there was a tag named Derek, I open it like this, and I need to say I'm done describing the Derek guy, so I have to close it by putting a /. So in that same way, that is how we have HTML here, and then we have HTML2 at the bottom where it is being closed with a /. If I don't put a / here, the page might break. It would be expecting me to close it. So most tags are being closed, and then we have self-closing tags. Those tags start and they close themselves. So it could be like this, Derek, maybe Derek language is equal to EN. And then the next thing you will see is something like this. So as you can see, this is what we call a self-closing tag. The tag opened over here, but then it closed itself with that / at the end. That is just another variance, all right? So now moving back to our HTML description, the next thing we want to look at is within that tag, right? We need to specify another tag, which would be a head, as you can see. And then we also have what we call the body. Now, all of this is a bit much, so I'm going to do Control S to change the structure. Right, so I hope this makes it clear. So can you see? So that means head and body are under the HTML. You get the point. So the tag has a sub tag or extra elements within it. So the head, this is where we define the title of the page, right? And you are going to see it in the browser shortly. So we have a title. I'll link all of this to the, and then we have a paragraph, right? So let me go back to my Word file to pick up the things I had. So I have a header, H1. This is our heading. And then the body was, this is our body. And then we had another one named conclusion. So the same thing. Copy, paste. So we had conclusion at the end. All right. I know this is a bit much because of there's too much coding. I know you're not supposed to be coding, but follow me closely here. So we have our body. Let's put some space in here. So as you can see, there's a line saying that all of these belong to the HTML tag. Now, within that HTML tag or within that web page, we have defined a head, and that head contains what we call a title. So we would say professional, right? So just this, I'm going to show how it looks in a browser so that we can all see that. So new share, the full screen. All right, and then I'm going to try to run this. Run without debugging. Chrome. And it should pop up on the right side. Can you see this?
Yes.
Exactly. So whatever we did here, right, the title, okay. It may look small, but the title is over here at the top of the page. So if you visit any page, you visit Coding Dojo's website, what you see at the top side where my mouse is actually the title. And then H1 is just like the heading we saw in Microsoft Word. As you can see, Microsoft Word is right above it. The same thing, right? So we have our heading, and then we have our body, and then we have our conclusion. So this is actually a web page which has been processed by the web browser. If I want to view what was happening, I can just right click, new share. I'm going to share this new browser. And then I'm going to right click on the page, go to inspect or view page source. I think view page source is good. And can you see this page? That's the page right there. Same thing. So this is how it works. So back to our Visual Studio. Let's add 2 more things and then we move on. All right. So at this point, we have created a web page. We've created the nicest web page in the world, but we need to beautify it. We need to put in some, we need to put in some colors, right? So that is where CSS comes in. And for CSS, there are different ways of doing it. We could just, you need to put your CSS in your header section. So we start CSS by saying, we are about to tell you about a style we have. So when I do this, you can see that, right? I have style, and I can put in my beautification in there. So I want to beautify this H1 guy here, or let's say, yeah, just the H1 guy. So I'm going to do, this is the syntax. It also has its own syntax or structure. So you put in, so with that, you specify the element you want to, or the tag you want to deal with, and then you can put in some code in there. Now, this is a sample of the code you can put in there. I could change the color. So I could just say color, and I put in a colon, and then I put in, let's say, green, right? Then I put a semicolon at the end. Now I'm going to reload this page. Let me share my screen again. So I'm going to reload the page. And can you see that the color of the page has actually changed to green? Because now I'm using CSS, which is the style sheet or a style, to beautify it. So HTML exists. I'm using CSS to beautify it. Now, where does JavaScript come in, which is a bit of a stretch? But then JavaScript, for that, it also has a tag. And I'm going to go back onto our page. And for JavaScript, we just do scripts, right? So for that one, we start by just saying we want to put in a script, and the script source, in case we have an external page we want to link to, we can link to that page. I don't want to talk about linking at this point because we've gone too deep into coding. So yeah, beautification needs to be used more, Matthew. I totally agree. So I'm going to take away the source because I'm not linking to any external document, and I can just put in my JavaScript right away. Now, JavaScript has a method named alert, and alerts would basically put a big dialog box on your screen saying, hello, this is professional. So all you have to do is to script, and then in the middle, you just type in alerts with brackets, and then you just put in some quotes, then you put your text in between. So this is the most beautiful professional websites ever. I know it's an overkill, but enjoy. All right. So what I've done is that, so what happens is the page will load first of all, process the style whilst it's loading the page. And then when it is done loading the body and everything here, it would now process the scripts at the end of the page. So I'm going to reload, share my screen again with both. So our heading is green, our body is there, our conclusion is there. So once I reload, our alert should pop up. And as you can see, as beautiful as it looks, this page says, this is the most beautiful professional website ever. If I press OK, the content of the page will finally load. So let's just share the code, the website once more, right? I hope this is big enough. So if I reload this page says, this is the most beautiful. Sometimes when you're leaving a page, let's say you're trying to make an order and then you're leaving the page without completing the order, you can see some of these alerts. It comes on your screen. Hello, I think you're doing this. You should have done this. That is what an alert is. So this is the most beautiful web page ever. I press OK, and then the content is changed. There are ways of changing this content by inspecting the elements, doing on and on, but that is too much for us today. So I'll give you one more chance to take a look at the code for like 10 seconds. But then while you're looking at the code, I want you all to take a look at, good. So when I clicked here, can you see this thing that is showing? HTML, head, body, H1PP, and then the script.
Yes.
So this is the structure of the page I just created. I clicked on Visual Studio, gives you that functionality of clicking and then seeing where you are on the page so that you can easily move across the page. So our HTML tag at the top, the head. If I open the head, there's the title, the style, and everything. So as you can see, this leads us into our next topic, which will be the document object model, which is the DOM, where we have a structure and we want to modify that. We want to modify these things programmatically, and we would use this to get that information. All right. Now, at this point, we'll go for a 2-minute break, and then we'll resume with the lecture today. All right. If there are any questions, you can also throw them at me. I'm here to answer them.
Derek, I was wondering, well, what's the difference between an object and an element?
An object and an element. All right.
Yeah.
So an element is actually the content that we saw on the page, right? So that P tag we saw was an element on the page, right? So, but then an object at this point, this is where we are sort of transporting our information, where we are saying we want to deal with this in a JavaScript related form, object-oriented situation, where everything on the page is no longer an element, but then it becomes an object. How do I explain this? So we are trying to, let me do this here. It helps, right? And Matthew, Matthew, if you are here, once I'm done, you can also add your 2-piece to it. All right. So we have, whilst we're on the page, right? We had our HTML here. We have a structure. And then everything here, we have our H, we have our P, which is our paragraph, and then on and on and on, right? So with the object, we are trying to sort of say that when we get to the document object model, we are going to convert all of this into an object where the whole thing qualifies as one big object, and then we are trying to sort of manipulate it. So within that object, we would have elements within that object. So this would be our HTML document object model, the current document we have. And then within that, we can actually manipulate each element within that object, right? This is a bit of an object-oriented concept where it's also a whole different topic on its own, but I hope that answered your question. Yeah. All right, you're welcome, Milo. Got it right this time.
I do have a question too, Derek. I was looking at the Coding Dojo platform, and like under belt exam history, it's like we have like a Java's belt. Are we ever gonna unlock those, or is that like something we need to do on the side or speak to someone about it?
Mr. Matthew, are you here? All right. So
that's me. I'm here. What's up?
All right. Did you hear the question? I think that's
I did. So Zori, were you asking that you see like a Java belt, a Python belt, all that other good stuff?
Yeah, like programming basic belts. I was wondering if like we're ever gonna unlock those, or
Great question. The as of right now, the developers that did actually the platform, the company that is doing that, they did not separate the belts. So you are seeing all the belt possibilities of all the stacks, just in case you wanted to take the programming course, take the Java course, take the data science course, et cetera, et cetera. We are just going to be the core, intermediate, and professional belts.
Oh, okay. No, thank you.
Absolutely. Great question.
Matthew, I think I need to schedule an appointment with your chiropractor or something, because
I see you're getting limber over there.
yeah, it's like think I need to start running again because
It's these 360 monitors.
I totally agree because I have to be like, I can't take it anymore. All right, let's resume right now. All right, so the next thing we are going to look at is DOM, Document Object Model, where I think when I show the page, there was some interesting stuff on the page. And based on that, in plain terms, DOM is what is generated after your browsers process the HTML. You remember I said what you see in your browser is processed HTML. So yeah, I'm going to give everyone like just 10 seconds to return to your screens and your laptops and your phones so that we can continue. All right, moving on. So we have these, the DOM is what is generated. And when I did view page source, which I showed, I think, let me get that here so that it would be on the same screen. All right. Good. Okay. All right, so when I do this view page source, as you can see, I'm seeing the structure right here. And it's the same thing that the slide is showing us here, where you can see HTML, the head is our title, the body. This is a link, href A is for the link, anchor tags, and then H1 for the header, and then the body, right? It can be vulnerable to XSS because at that point, it's like you have access to modify anything on the page. And if you can see this diagram here properly, I know it's a bit blurred out, but try squint your eyes a little bit. And as you can see, so the document, the root element, which is the HTML is here. And then we have, see if I can zoom into this. Oh, it doesn't have an effect. Interesting. All right, so we have the HTML elements here, and then the body, and then the head. As you remember from the example that these are all standalone. So these are all objects on their own. And then under each of them, the head had the title with the text. Now the H1, which is under the body tag, that's the H1, which is an element, also had a text, which was, this is our website, blah, blah, blah. So this code you see here is converted into this way so that programmatically we can modify it. We could just look at this and then say that I want to say document.get element, and then I could get that element, right? Programmatically in JavaScript, we can get an element by just specifying that document, going in here and then getting this particular element. Now, when it comes to URLs, there is a concept, which is URL encoding. And sometimes things like spaces cannot be, you can't, let me do this here since it would be clearer. All right, so hello, no, something like that. All right, now you will notice that even though I put a space after the full stop and the no, right? In the URL, which looks a bit small, they replaced that with a plus, right? Which is, I think, in a way, Google used the plus to sort of, where is our slide, right? Google used the plus in a way to sort of encode spaces, right? But when it comes to percent encoding, most of the time you would see %20 to replace spaces. In most websites, if you use spaces, they will put %20 there, because once there is a space in the URL site, it confuses the web server. It would not be able to consolidate that data together. So sometimes this helps so much when you want to perform an attack. Let's say you want to execute JavaScript. You remember the JavaScript you just did? It looked like this, right? You want to execute this, but then there is a server that is going to stop you from running this particular code, because once it notices that you are putting in JavaScript, it would actually not process it at all when it has input validation. So the idea is you would actually encode this using some of the links. Sometimes there is a URL encode converter somewhere. Let's see if it will encode something like this. So this is a link I picked from here, and it allows you to encode your URL. So if I do this, let's see. Can you see that? It would, what it does is, let me zoom in a bit. All right. And if I put this in a browser directly on any website, I would be flagged. It would say I'm putting in quotes. But then if I do this, I come here and I encode it in a way where URLs can consume it. It would convert every single symbol into the ASCII representation. So I used a greater than sign. Where is that? It should be here somewhere. Oh, come on. I think we didn't add it to this list, but let's find something that I used that could be. Let's see, we have single quotes were not done. All right, so /, yes, I have a /. So a /, it's quite in, yes, that's a greater than sign, perfect. All right, so this is a, wow, did I just forget my greater than sign, less than sign? All right, so this is a less than sign, and this is a greater than sign. And this, the percent encode is %3C. So when I come back to this website, you notice that anytime this thing is shown, it is translated into or encoded as %3C. The same thing here. And then the other one, which is the less than sign or greater than sign, would also be encoded as that. So I can pick this up, copy it, go on to maybe my victim website, and then put this in the URL, assuming it's expecting input, put this over here, and then see if it's going to work. And then they have input validation. So please include ads in your URL, blah, blah, blah. So they caught me. But in other places, they might not have caught me. I mean, I coded this, so it has to be secure, obviously. But let's see. Yeah, it didn't work. So at the end of the day, I hope you understand what the percent encoding is. It helps you evade some of these input validation mechanisms that exist. And then HTTP status codes, you remember we found a slide where when we did the curl, we encountered some of these situations where we had, you could see 200, you could see 301. When it was redirected, we saw 301. When it was successful, we saw 200. So anytime you see 200, it represents a successful response, meaning whatever you requested for exists. If you see 301, right? So 200 successful, right? Or the page exists. 301, these are the most important things you should take note of, means that a page has been moved or deleted, so redirected, right? So 301 moved or redirect. Then we have 404. I think you might have all seen this before. If you request for a page that does not exist, you are going to have the 404, which means the page that is not found. So you might have to check, and this qualifies as a client error, meaning you, the person that requested for the resource, might have made a mistake with the URL you placed in. So check it and then do it again. So page not found, right? And then when you see a 500 error or any of them that has to do with the 500s, that mostly is a server error, which could mean that the code might be problematic and they're already experiencing issues. So you need to, it's not your fault, it's the server's fault, and it's not able to accept new requests. Okay. (201) means something was successfully created. Put is a form of a creation on the server. So yes, exactly. So, okay, someone asked the question, didn't see that. Yes, yes, yes. Thank you, Matthew, for answering that question. So we need to come back. So I'm going to put this in a chart. Where's the chart? All right, now there are sessions and cookies, and this is a pretty straightforward concept. So HTML, CSS, all of that does not have a way of keeping information, right? How do you log into Facebook and then come back and then they keep you logged in and you're always like, oh, I'm logged in? It's because they use these storage functionalities, sessions and cookies, right? So cookies, not the ones we eat, but computers have cookies, and cookies are client-side files on a local computer that holds user information. So cookies are mostly stored on your browser, in your browser, and then this information is locally stored on your computer and is mostly not secure unless the developer goes the extra mile to set the secure tag. But then sessions are on the server side, meaning whoever created the application is actually keeping that information. So they put all of that on their servers. It is used to keep information about whatever you are doing on the website. That is how Amazon is able to keep track of whatever you've placed in your cart. Even if you log out and come back 3 years later, whatever you put in the cart is still there because they are able to have that information logged in. But then when you log into a site, a session is created for that period where you are logged in. And then once you log out of the site, that session is canceled, as in it is ended. So with sessions, you need to always, log in. If you log out, the session is ended. But then I think when I said Amazon, I created a website where I think web browsers, I think Mozilla created something called local storage. And I created a whole application and I used the local storage as my database. It was a pretty weird project. All right. Now for our 10-minute tactical today, okay, we are going to do an MSF Venom project. All right, so please do well to pay attention. We are going to take a screenshot of this and then put it. So this is the cheat sheet. Going to put that in the chat. We are going to go into our breakout rooms again and then do our exercise. So all of these exercises we actually taking you to a particular point. Next week's exercise is going to build on today's 10-minute tactical. And then you're actually going to enjoy it more because you're going to have a reverse show and all of that. So this is not just for fun. It is to give you that skill of exploit creation and to make you better at it. Let's delete this. All right. So MSF Venom is actually a project that allows you to create your own payload. And then once you create the payload, you can actually get information back from it. But today we are going to create our payload using the cheat sheets. And then I know you have all encountered virus total in the past where you all went, I think IOCs, I remember, yeah, the IOC assignment, you went to virus total, put in your IOCs, and then you made a report on your findings, which was really nice. So today you are going to craft your own payload, put them on the virus total website, and then you are going to discuss it with your group, what you found. We have 10 minutes to do this. It's going to be very quick. All right. So cleared, close. We share with Kali. All right, can you see my Kali? Is it big enough? Is it small? Close this guy here. Close up terminal. All right, so today's, copy this link, open it here. Open the cheat sheet. All right, so this is the cheat sheet for MSF Venom. And with MSF Venom, we can create our own payloads, right? So today we are going to, if you get on the page, we are going to scroll down to the reverse shell section. And then with your group, you are going to copy this, the reverse shell command. There's a copy sign here. Copy that, bring it onto your Kali, MSF Venom. Right? So MSF Venom is a Metasploit standalone payload generator. So we are going to generate our payload, and then we are going to move on with that. All right. Clear my screen. So I'm going to paste that command in here. And then this command is already done. All I need you to do is to replace these parts, the ones in the bracket, with your own information. So first of all, you will have to create this L port, change it to whatever port you want to listen on, right? This is your listening port as an attacker, right? This should have gone in line with reverse shell and bind shells. We'll explain that next week. But once you hack a target, you want the target to connect back to you because your exploit can do that. So with that being done, we need to specify that, okay, whatever exploit I've done, connect back to my machine or my laptop using this port, maybe 555, 4 5s, right? And then the IP address, the L host, for those of you that have done the Eternal Blue lab, the L host is your IP address, your Kali's IP address. So that would be, so my Kali's address, I need to check that shortly. So split terminal vertically, ifconfig. So my IP address is 10.0.5.4. Close this. Yep, I think I ruined the terminal. All right, so same thing. .0.5.4. And then the ports would be any port of your choice, as long as there's no other device that is using those. So most of the time I go very wild. I choose a very wild port. It could be 999, just 4 nines, just to confuse the victim. And then what you are seeing here would be the name of your file, right? So this would be like hacker payload.exe. Now let me explain the parts of the command, right? So MSF Venom, right, is the tool name. P is the payload type I want to create. So P will be our payload type. Let's get our document here. Right view. Anyway, so I know you can see that. So P is our payload, right? Move it down a bit. L host is our attack machine IP address. And then L port is our attack machine port, listening port. So L host is listening host, right? Now F is the format, right? So here you are specifying the format that you need. And we are saying that we want whatever exploit we are creating to be an exe format or executable file format, which is what Windows machines used, exe. If it was Android, we would have used APK, right? If it was, I almost said iOS. I've forgotten what iOS uses, but I hope you get the idea. So F is the format of the payload. whatever we are creating, right? And then when you see this sign basically means that this sign, which is the, that's not a pipe. It means that whatever command we are doing here, right, the result, we want to use that result to create a new file, and this should be the name of the file. Whatever command, good, a redirect. Thank you, Matthew. So whatever command we have here, we want to use its result. We want to direct its output or result into a file, and we want to name this file hackerpayload.exe. Now let's assuming if this file already exists and you want to overwrite it, you would have to use a double redirect, right? Good. And just like Matthew said in the chat, it is used for hitting file save. So assuming you've already created the file and you don't need to create a new one, if you do a double redirect, it means that you are overwriting an existing file. But if you do this, it means you are creating a new file with that name. So this is redirect the output, which is into bracket to save the file. So you have to specify the file name, okay? So this is what you are doing today. You are going to create this, and once you are done, once I click enter, I am going to, it's actually processing. So no platform selected, so it's going to choose the platform as Windows based on the payload I selected. No architecture selected, is going to pick it based on the payload. No encoder, and the size is the final size of the exe file is 73 kilobytes. Now the payload itself is 354, but then in totality it is this. I forgot to explain this, which is the payload we are creating, and we picked it from Metaprater. So it picked it from the Windows directory of Metaprater content, and then it picked the reverse shell. Next week, we are going to explain this guy properly, all right? So once I'm done, I could go into my folder, my Kali folder, and find the hacker payload file. So let's find the hacker payload file. That's it, hacker payload file, 72 kilobytes, all right? So that is our task for today. You need to create this, and then once you're done, you go to virustotal.com. I think you already know how to do this. Upload that virus. Sorry, it's not a virus. Upload that nicely crafted payload, and then discuss the results you found with your team members. All right. We have 10 minutes for this, and your clock starts now. I'm going to take a screenshot. All right. So if you need to step out as well, you can actually step out. We'll record this and you'll be able to follow at a later time. So breakout rooms are being created. Breakouts. I need to make some people administrators. I know 5 rooms assign automatically. Open breakout rooms. Participants. Richard. Hosts. Jasmine. You host. So we're going to need about 10 minutes more. So I need to close a few things here. Need to close sharing. How do I? Yep, power off. Close. All right, so I actually hope looks like you all enjoyed. Oh, QR code. You guys have ideas. I like it. Right. So we have two things to look at: scanning for vulnerability scanning tools, and then enumeration tools. We are going to look at these three tools very quickly to see what they could do and how much information they could give us. So in order to do that, I'm going to run two machines, one for, need to close this out. So going to run two machines, my Kali, and then my OWASP machine. Oh, my RAM is about to die. So MS7 I'm off, Google Drive off, this is off, All right. So whilst it is running, these two tools we are looking at. Oh wait, I'm not sharing. Sorry. So whilst it is running, we are going to look at a tool named, I think, Dirbuster, which is used to brute force directories and web pages. And then we'll look at Nikto, which is used to scan for vulnerabilities on websites, and then Wpscan. So we are going to look at these three tools. And then, all right, my Kali is on. So we share screen to show my Kali. Let me know if you can see my blue. All right, can you see my Kali?
Yeah.
Perfect. All right, let's get to it. All right, we are going to look at three tools quickly. All right, so the first tool we are going to look at will be Dirbuster. And Dirbuster is used to enumerate a directory, right? Sort of find out what pages are available on a particular website. So for that, I go to search, find Dirbuster, click on the first one. All right. So Dirbuster, as I said, is used to find directories. Now, the device we are trying to attack is the other virtual machine I turned on. And that machine, the IP address is, to make this quicker, is 10.0.5.5. It is called the OWASP. It is named the OWASP Vulnerable Web Application, Broken Web Application Project. So for that, all I need to do is to put in my IP address here, 10.0.5. And then it's going to go directly. And this is another virtual machine I've turned on, just like you did with your Metasploitable 3. This is another machine just like that. And it's called the OWASP Broken Web Application. It has a lot of broken applications which we will see. There are a lot, but we want to focus on the WordPress one, for example. And this is the WordPress site. Now, there is a site, you don't know the pages available. You don't know what pages you could get into. There's nothing you can do here. But then because of that, there's what we call we have enumeration for web applications. WordPress is a content management system, just like Wix. It's just for creating websites. It makes your work easy. You don't have to do all the hard work like what I did earlier. So I'm going to minimize this. And then I'm going to come back to Dirbuster, right? So in Dirbuster, first of all, as I said, it is for enumerating that web application. So I need to put in my URL, which is http 0.5.5. And I need to specify the port, or I can just ignore it. Just do that. Is this big enough? Make this small. Smaller. Good. Perfect. So I specify the URL, and then I need to specify number of threads, how many pages I want to be checking per second. I could go 20, I could go 10. We just go for go faster. It's my machine. And then the scanning type, do you want to use a list to view the pages, or you just want to do pure brute force? I have a list. So if I click on list info, it's going to give you the several lists it has, and then the directories where they are located, right? So this list, Apache user enumeration list, contains 8,916 usernames. This one, 10,000, on and on and on. Now I know where these files are located, just like we did with Nmap. So just to visualize where the files are located, instead of just going there direct, let's go there manually with the File Explorer instead of going through the terminal. So first of all, go to File System, and then they are located in user share word list, and we find what we need. So user share, just like the Nmap script, word list will be at the bottom. So word list, where are you? Word list. And then I need to use, we are using Dirbuster, so we could use the Dirbuster too. So Dirbuster, and then we specify maybe directory is small, right? Now we need to, it's like, what does this contain? You remember the example with the password word list? The same way we have another one which has to do with directories, right? So let's open it with mousepad to see how it looks like. And this is how it looks. So it is going to check the page. Is there a page named index? If there's a page named index, it would tell it, like, based on the response it received. Remember, request response. If the response is 200 or 200, it means that there's a page like that that exists. If the response is 404, what does it mean? 404. Put that in the chat.
Not found.
Yes, not found. Perfect. So exactly, it's an error, and it also means not found. So it's going to check all of these one by one to the end to find out. So just like the password thing, we are doing this, and in a way, this is also called fuzzing, F-U-Z-Z-I-N-J, which means we are trying to find out what directories are available by going through. So I'm going to close this, don't save. So I'm going to use the smaller one, but to do that, we need to specify that in the application, which directory we are picking the information from. So I'm going to bring that down so that we can copy the URL. So I'll go to browse, and then I need to go back to the first directory. So I clicked here, went to the root directory, user, share, just like what is down here, as you're seeing. So user share, word list. Kali contains all these word lists for free. So word lists. And then I'm looking for the Dirbuster folder. I found it. Then I choose small because we don't have the time. So small. So now I've chosen what word list it should use. And I can skip everything here, but then I put PHP here just for the sake of it, right? So it's going to look for directories, look for file extensions, on and on and on. So when I click on start, is going to have its way with the application. It's going to like just keep hitting the application. So if you can see here, it will keep hitting the application to see if it is finding any files. I'm surprised it's still not finding anything. Okay, so as you can see, it's populating the directories it is finding based on the input I gave. But as you can see here, look at the response code. 503 means a server error, right? It's one of the server issues. So 200 means that that page actually exists. Every other thing besides 200, we don't like it. Right. So you can actually stop the scan because we don't need this type of scan. Now, the idea is, I told you there is a WordPress website, and this is the URL. So we want to just check. We want to check what pages this WordPress site has. So I can just copy this. So WordPress, because I want to enumerate that WordPress site I found. It could be any other site. Any other site you find, always use Dirbuster to go through it to see the start. And then I'll go, so there are different, there's scan information, results, list view, and then there's also tree view. So tree view is running. And I think I should have cleared this particular scan before we had so that it doesn't interrupt what we are doing. All right. I'm surprised there, but is it even working? Nope, nope, nope. It's not giving us the information. Oh, it's still using 10.0.5.80. I thought I changed it. Yeah, I thought I changed it to WordPress.
If you change the number of threads to 30, would it make a difference?
Maybe, let's just see. But most of the time, 10 is fine. It can do 10. But let's just go 3, just like you said. But regardless, it is not changing the, see the URL it is scanning.
It's
So
I suppose it's normal if
yeah,
it's running. So it would take like hours or less than a day to complete the entire thing.
I agree. So what I'm going to do, I'm going to leave this application. I'm going to exit, come in again so that the URL changes because it's like it's messing with me. So again, Dirbuster. All right, so we have Dirbuster here. Put this in quickly, HTTP 10.0.5.5. And then we go for WordPress. These guys are wicked. User share. Word lists. Gobuster, small. All right.
So for the target URL, is there like a port A5 under 5?
So for here, it's actually using the default port, which is port 80. So there wasn't any 8585. But then for your assignment, right? For those of you that have done the assignment, you would need to put that particular port here because it is different. But for me, because I don't need that, I could do 80 because it's still correct. All right, so for the assignment, it would change, but for us, it would not. So let's see.
Okay.
Oh my word, these guys do not respect me at all. Looks like the same response. All right, so we are going to minimize that tool, go for a different tool that would listen to us today. All right, so I'm going to use Gobuster. All right, so for Gobuster, that's the command. I know it's like, how did we get that command on the screen? All right, so for Gobuster, it's the same as Dirbuster, but then you have to specify the word list. It's the same thing, but you need to specify the word list. So I go like WordPress, and then HTTP. So Gobuster, I specify that I just want to know about the directories, specify the URL, the word list, and then once I press enter, it's supposed to enumerate that particular website on our behalf. So it's found the license 200 index php.ini, on and on and on. So all right. So the result of this scan is the directories available, emphasis on the status 200 ones, and then see the 301s were redirected to a different URL by just adding an extra one. So there are so many folders that have been found, where WP settings, WP links, WP atom, on and on and on and on. These are, I think these are folders. Yep, all these are folders. So in a way, I've not visited the site myself, but I've been able to enumerate what folders and files are available on that site. If I want to find more secret files and folders, I would use other word lists. So this is the command once again, Gobuster, the directory, meaning I just want to know about the directories. And sometimes if you're trying to hack into a box, you would find that some directories are hidden, some directories are password files hidden all around. So that is why these fuzzing activities is very important. So at this point, we'll bring an end to today's class because we are far over time, but then we will surely continue this before our next class starts, which is on Tuesday. And then besides that, I know most of you are working on the lab, and then you have Wpscan. You would notice all of this in the scan. I think there will be Nikto, and then there will be Wpscan. So, all right. So I need just 2 minutes to run just these 2 scans, and then we'll explain what they mean by next week. So closing this on the side. So I'm doing the same thing. Nikto is a vulnerability scanner. It's going to tell us if there's a problem with the website. So Nikto with the H for the host and then the URL. So if I press enter, it's going to start scanning the website on my behalf. I need to split this whilst Nikto is running. And then Wpscan saying URL, HTTP 5.5. And then I think for this, we don't really do anything. All right. So it looks like our Nikto scan is done, which is our vulnerability scan. And it's going to provide information, especially what server is running, which is the first information that is here. So the Nikto scan is done, and the server that is running is Apache 2.2.14. And then it tells you what vulnerabilities it has found, especially cross-site scripting is XSS. It's saying that the protection header is not defined. So that is very dangerous. And then it goes on to provide information about OSVDB, that is open source vulnerability database of what vulnerabilities it is finding on that page. So that also provides valuable information. Now, from this point, you get to realize there's a WordPress site scan, WordPress site running, and then Wpscan provides more information on that. So with Wpscan, all right, this has been a long class. Yeah, does not seem to be running. That's a long pause. All right, finally started. So for some of you, when you try to run your Wpscan, it might come up and ask you, it would not run probably because at the first run, it needs internet to sort of update its database. So make sure you are using the right network so that you could have access to the internet, all right? And whilst this is running, it's basically going to tell you what things are running on the WordPress site and how some of them are vulnerable, their CVEs and all of that. So if this is running, it gives you information on what exploits can be used, and scanners can be used in Metasploit. Rapid7 results belongs to Metasploit. And then galleries that are running. So this plugin is also running. I'll explain all of that next week. So these tools are very essential. I know you have labs that would run across these lines. So do well to go through them. If you have any questions, you can look through the lab. You can look through the assignment.